So, who's Erik? Erik's the boss, the guy who got us all together for this first Toolroom Takeover. If you haven't heard of it, and you're wondering what this Toolroom Takeover is, we're a bunch of people with machine tools making stuff for each other. And in my case, I drew Erik. So I guess I'm the one in charge of making the boss happy.
Did I ever mention that I'm a musician?
Erik may look like a young Sid Vicious who got into computer engineering, only to drop out and chase the good life as a machinist. But don't be fooled, he's more Sid than Sid. And when it comes to part-off blades, he's more vicious than vicious. He runs his machine shop from his flat in London, and if hauling tools and machines upstairs wasn't enough, the neighbors gossip about how he's always carrying massive amplifiers up there. Another one goes in, none ever comes out. Those who follow Erik might have heard him say he's a musician, so that's his excuse. And if my job here is to make him happy, then I guess there's only one thing I can build him.
We happy?
An amplifier. I'll need a transformer, a turret board, an output transformer to drive an external speaker, and since we're already committed, let's add a built-in speaker too. After all, I'm not the kind of guy who sends things out incomplete. I also need to include a machine component. That's rule number 1 for this club. Yes, nerd knobs are cool, but what I really want to make is a custom power switch. Now, as you know, metal is conductive, and killing Erik is something I'd like to avoid. So my power switch can be switching mains power, at least not directly. I need to convert mains power down to 5 volts for the switch, which makes it safe to touch, and then use a relay to actually switch the mains. The only problem is, I know nothing about electronics. But I'm still gonna tell you exactly how I pulled this off. I started by ordering some PCB blanks. I thought I could laser engrave them, but then I learned FR4 boards are made of fiberglass, and fiberglass melts under laser heat, or at least that's what the internet will tell you. What I basically needed was a way to convert mains voltage to 5 volts, and then, with a 5 volt signal, trigger a 10 amp relay. That's something you can do using a couple off-the-shelf modules. Cheap and ready to go, straight from China. All it takes is a couple of wires to hook them together. So, I copied them. I looked at the components, figured out what they were doing, and tailored the design for my build. Then I tested the main circuit on a breadboard, and it worked, mostly. After some fine-tuning, I was ready to design my first PCB. Learning KiCad led me into my latest love-hate relationship, but I was determined to continue, even knowing full well each click was as unpredictable as my micrometer. After I dropped it. The boards I received were obviously bent, so I used these clamps to make sure they sat flat on the laser pad. Fixturing them properly also made sure they'd return to the same place every time. I tried a bunch of laser settings until I found a sequence of passes that didn't burn the fiberglass. And before you ask, let me ask you, where do you get your FR1 boards from? It's just a 20 watt laser, so it takes a while to get there. Meanwhile, as I checked the pads for continuity, the Bamboo Lab was already printing parts for the next step, the solder mask. Here's a microscope view of what you can expect from this process. The traces look well defined, and there's no sign of copper left in unexpected places. I've never done anything like this before, so if I'm missing something, let me know. I decided to go with 2.5mm traces for the AC section, which I'm separating from DC before applying the solder mask. These physical gaps increase both clearance and creepage distance, which is important when you have AC and DC sharing the same board. Basically, the slots make it harder for electricity to jump across and cause a short. Additionally, I made sure there's at least 6mm between AC and DC traces. The relay pins are obviously a limitation. I can't change those, but that's why I added a slot around them. The DC traces are 1.5mm wide and the circuit is rated for 600 mA. Actually, if you subscribe, I'll do the right thing and add a 500 fuse. The traces are probably bigger than necessary, but that's what you do when you're not confident in what you're doing. Applying solder mask evenly on a board this size wasn't as easy as I thought, so after curing, I resorted to methods I know well. Yup, sanding. Just the top, to make it flat. After laser engraving the silkscreen layer, I flipped the board to do the solder pads. This required tweaking the laser settings a little bit, but in the end I managed to remove just the solder mask without ablating the copper. And now, the real reason I wanted the top layer flat. This was the hardest part of the process for me, and probably unnecessary, but if you get it right, it looks beautiful. Finally, I cut the board using settings that were probably too aggressive and got ready to drill holes for the components. But Erik texted me. He asked if I could use my fiber laser to create scaled-down versions of Queenswall signs. The round logo in aluminum and the yellow, the safety sign, in brass. I can do it, but I want to help Erik, but there's no way I'm replicating that wall sign in brass. From what I can tell, the original is painted sheet steel, with stenciled lettering, pretty much like these old garage signs. I love this kind of stuff, so let's try to do it justice. Given the size, I think a vinyl cutter would be the way to go, but I don't know anyone who has one. However, I do have a 3D printer. Yeah, finally! Yeah, this was the third one I made. The first didn't turn out the way I wanted, so I made the second. But that one was just as bad, so here we are. And this one isn't perfect either, but I don't have time to make another. I really need to get back to the PCB. But first, one last detail. I wish the letters were better. The problem was, when I removed the tape, the stencil moved, and I had to take it off while the paint was still wet, because my other two attempts failed for that reason. I was letting the black dry, and the yellow paint chipped when I lifted the stencil. Anyway, I hope Quinn likes it. Erik's waiting, so I'll get this packed for shipping. Oh, by the way, you'll never guess who's gonna send me some Yandees. So, since the beginning of this project, I had this idea of making a switch with the code. 4 wheels with 26 letters each. When Erik's name aligns at the top, the M turns on. Any other combination keeps it off. Pretty simple. All I had to figure out was how to get that click feel for each letter, how to make the electrical connection happen, and how to keep it isolated from the wheels and posts. Even though it's only switching 5 volts, a switch should always be isolated. I spent some time in CAD trying to come up with a solution. That usually helps, but this time it didn't. Total creative block. That's why I started with the PCB first. I tried to buy some time, hoping the switch would figure itself out. Soldering components to a board was also a first for me. But when you have friends who support what you do, and if needed can lay out complex concepts in a way that makes you think, hey, I totally got this, life gets better, and your dreams start to feel tangible.
There's really only 2 things you need to know about electronics. The first is they should be avoided at all costs. But if you can't manage that, number 2 is that the smoke needs to stay inside.
Thanks man, solid advice. This Euro-type M&M can absorb voltage spikes that may come from the AMS transformer, especially when the relay turns off. We don't want those spikes making their way to the relay because they can cause arcing across the contacts. and that's guaranteed to wear them out faster. But the varistor is not alone. I've also got a resistor and capacitor in series, and that's called a snubber. It helps smooth out the switching and cut down on electrical noise. I'm pretty sure the relay is gonna flicker sometimes, because custom switch, so I'm just trying to keep this whole thing from self-destructing. So one by one, my board began to fill with colorful components. And if a little bit of solder is good, then a little more must be better. That's when I realized what PCB really stands for. Potentially cooked board. As soon as I could test the DC part of the circuit, I did. I didn't find anything strange, but you probably did. Like this fan or the lighting connection. None of that makes sense on an amplifier, but we'll get to that later. The AC to DC transformer was added afterwards, and then I left the board running for a few hours. I checked the temperature from time to time, and nothing was heating up. Actually, the whole board was pretty cool, but right as I was finishing up testing, I found this problem. If you didn't catch it, after unplugging the circuit from the wall, the board can still be turned on for a few seconds, and then it dies by itself. Now the problem is obvious, it's a charged capacitor, but I thought it was the filtering cap I have after the transformer. After testing, it turns out the problem was actually the transformer, which is a closed box. I was still measuring 5 volts for several seconds right on the transformer's output legs. That's even before my capacitor. So to fix this, I tried adding a few different resistors across that cap. A bleeder resistor basically helps drain the capacitor faster, but it does use a bit of power, though in this case it's probably nothing to worry about. But since I didn't want to make a whole new board, I just soldered it on the back. That seemed to work for the most part. It's not perfect, but I managed to shrink the window to reproduce the problem down to about 1 second, or pretty close to that. And with that done, it was time to put the PCB away. As for the switch, I still had no clue how it was actually going to work. I was stuck with this idea of a tooth catching a groove on the back of the wheels for that satisfying click. But no matter how I pictured it, it always seemed awkward to machine and tricky to adjust. It just didn't feel right. But without a better idea, I figured I just needed to start. So I started, by breaking a chamfering tool. Then I broke another one. The third wasn't a charm, and his end mill snapped when I told it what happened to his chamfering friends. Yeah, I'm pretty sure Brandon jinxed me. So if my plan of not having a plan wasn't working, all I had to do was change the plan. And just to be safe, avoid chamfering tools. Now let's stop messing around and get down to business. I only need 4 rings, but I'll cut a few extra, because if you got spares, you'll get it right the first time. So I cleaned all these parts with brake cleaner. This is stainless 303, but it's incredible how isopropyl alcohol still managed to clean them even more. Ideally, I'd like to passivate everything, but I'm not sure if I'll have the time. Sometimes stainless rusts because of these tiny particles left over from the turning process. I wanted to make an amplifier because I thought it was cool. I'm talking about a tube amp, not solid state. First, I saw these DIY kits for sale, but everything escalated very quickly when I tried to confirm if they'd work for bass. I don't know if I mentioned that, Erik plays bass, just like Sid. Didn't. Turns out those kits are a joke. I mean, technically they make sound, but so does a microwave. After weeks of searching for a bass amp that was simple enough for me to build, I couldn't find a single one. So I did the sensible thing and decided to design my own. Now, in my defense, I had no idea about the rabbit hole I was getting into, but this was actually how the project started. One of the downsides of having a small mill like mine is the lack of rigidity. In this case, the issue might not have been the mill alone, but I was consistently getting a taper after each pass with the boring head. So before I went oversize, I decided to take it to the lathe. I bought this reamer specifically to help me finish this part faster. Just like what happened with the boring head, small boring bars tend to flex on deeper holes and produce a taper. So investing in a reamer seemed like the best way to get the hole on size. Well, not if it cuts 0.3 mm oversize. This might seem confusing. I mean, why go through the trouble of drilling a hole just to press fit another chunk of steel? Simple. Stainless is harder than mild steel, and it doesn't rust. And when I realized I started rounding the wrong side of the part, except I was wrong. It was the right side after all. There are 5 parts in this block, you just haven't seen them yet. Like this arbor from my slitting saw, didn't see it until I had to make it last night. As for my take on the bass amp, eventually I came up with a schematic, and I can't count how many people I bothered with it. I asked for help anywhere I thought I might get it, but there wasn't much feedback. Apparently, the words newbie and 400 volts don't make a very compelling pitch. Then my mill decided to start making new noises. But unless it's the bearings, there's no way I'm stopping the show now. I'm no stranger to persistence, and I don't quit easily. By this time, I had refined my schematic to the point where people started telling me I should just build it, test it, and then start fine-tuning it. That was when I realized I'd actually need to tweak components until the amp sounded good. I wasn't expecting that. I thought I could come up with something on paper that was close enough to work on the first try. But that was a real problem. For one, I don't have a bass. I don't know how to play, and even if I had someone to help, which I don't, I wouldn't even know what sounds good or not. My hearing's just not trained for that. Not to mention time, I don't have much left, so that blind optimism I had at the start, it had now shifted into the worst kind of anxious pessimism. I spent countless hours trying to figure this out. One of the people who helped me was Mikko from Uralton in Finland. I can't thank him enough. In the end, he brought me back to earth and convinced me to do the reasonable thing. Build something tried and tested. A Fender Champ replica, the classic 5F1 amp. It's basically the starter kit for anyone getting into amp building. The only catch is, it's a guitar amp. Now, Erik plays bass, but I've seen the guitar in one of his videos. So, sorry Erik, seems like you'll have to change roles in your band. Honestly, it was my only way out. So I ordered the parts from Uralton and jumped back to the Switch. Speaking of which, I still had no idea how to make the wheels click. I just had a vision of the amp finished, and in my head, it looked beautiful. So let me share the new layout. You're looking from the top. The PCB I made goes at the back and connects to the turret board in front of it. The power transformer goes on the left, with the output transformer at 90 degrees. That's to minimize electromagnetic interference. Then, and I know it's unconventional, but the speaker will point up, far from the power transformer. The tubes go in between. The tubes are actually the cool part in this, so I want to add a square window so you can see them. Clear acrylic. Needs to be seamless, but access to swap the tubes also needs to be easy. Everything will be on a steel chassis, probably clear coated. I want the chassis to have this dull finish. The frame or cabinet will be plywood, 18mm. Rounded corners mean I need to learn how to make curve cuts, so I can bend the board to form a square. The good part is, since there's a window for the tubes, there won't be any seam to hide. For the sides, I have this roll of walnut veneer left over from something else. It's very thin and I don't have much. I need to test it first to see if it works. The top will have two separate pieces. The speaker side will be wood covered with this grill cloth, typical of Fender amps, and the electronic side will remain visible. I still need to confirm, but I'm pretty sure I have a friend who can cut and engrave some acrylic for me. All the switches will go on the acrylic piece, except probably the power switch, which is too heavy. For that one, I still need to figure out what to do. Some acrylic posts would be nice, to make it look like it's floating, but I don't know yet. Finally, the amp will probably get hot, so I'll add ventilation holes where it makes sense. And I'll have this fan underneath the tubes and the power transformer. It's a 12-volt fan that will run at 5 volts. It's dead silent and still moves some air. The only thing I don't like is the weight. It won't be balanced since all the weight is on the left. But this is like a record player. You're not supposed to move it around much. Oh, and finally, I bought these. €1 each. I still need to slice them into fine strips, but they'll be useful to hide the plywood edges. Think of edge banding, but one that can be sanded and matched to the sides. There are still some things to figure out, but everything has its place for now. And the reason I wanted my PCB to support some LEDs is because the interior will be illuminated. That should be obvious now. What's also obvious is that I need a guitar to test the amp. I borrowed this one, but it didn't work. Then I got this other one, but it also didn't work. I traced it down to a bad pot and already ordered a replacement. These side projects just don't seem to end. Meanwhile, I got these ready. I didn't really know where I was going with it, but they say things happen for a reason, and these must be one of those cases. I stopped for a moment and went outside. Needed to recharge my batteries for 5 minutes and get some fresh air. I was about to head back when I saw something. Dirty windows. But there was something else. A pigeon? I could tell immediately there was something strange with it. The way it moved, the way it was trying to open its little beak, I could feel it was trying to tell me something. I was perplexed. And then I heard the words I was so afraid to hear. Stop wasting your time and get back to work. I said, sure honey, and went back inside. But I couldn't shake that feeling. What was that little creature trying to tell me? What could it possibly be? And then, all of a sudden, it came to me in a flash. And I knew what I had to do. This center was already dead, and like all things dead, it was bound to turn into something else. 13 was the number I was looking for, and a custom plate is a plate I can't make, because to make it, I'd need a 13, and 13 was the number I was looking for. And then I heard the man, the pigeon man, the man with answers about time, life, death, and hope. He only said 2 words, and it was not "get back to work." Très près. 3 turns, 1 hole, 13 on the plate. The pigeon man said luck had nothing to do with it. Crank that handle if you can handle it. Albrecht's a German company, and this drill is way too small. If you're not ready for what's coming, click subscribe. Even the pigeon knew when to fly. One day you'll turn 40, and on that day, you'll realize the ratio had been wrong all along. Add 50 to make 90. A Z-axis motor would be nice. 3 turns, 6 holes. The 13 came to stay. And luck? Didn't I tell you it had nothing to do with it? Oh pigeon, save us from broken drills, taps, chamfering tools and the wandering rimmer. Erik's with a K, like knurling, or a key to a door that opens into this tool room. Come take over. Come if you dare, but bring your own calipers. My mic's as dead as that center, and I'm waiting on a new one from KBC, with a K, like Erik. Tomorrow I'll machine stainless. I want to use a ball and mill. So before I decided to use a ball end mill, I also tested a spot drill and a regular end mill. The spot drill didn't really work, it made the wheel feel too sloppy, I didn't like it. But the end mill actually worked really well. The ball end mill just feels right, so that's the one. Yeah, so this will be adjustable, and it's how the letters will snap into place. It's just a spring and a 4mm ball, basic detent. Oh, and the stuff I bought from Uraltone's already here too. The transformer is way heavier than I thought. The tubes are beautiful, I really like them. The speaker is a 6-inch, I know it's small, but this has to be a small amp. Going up to 8 inches would have made the cabinet a lot bigger, so I went with 6. Miko recommended this one, so yeah, can't wait to build this. What also came was my micrometer from KBC. KBC has been helping the channel from time to time with some tools, which I highly appreciate. But they have something for you as well, as this year they turned 60. In the description, there's a nice discount code for you. Thanks, KBC. Now, 2 steps forward, 1 step back. I thought I had someone who could cut and engrave the acrylic for me. Yeah, forget it, that's not happening. No more access to the CO2 machine. I had a quote from a company, and it's just too expensive. So that's another thing to figure out, how to make the top in acrylic. These were definitely the smallest parts I've ever turned. What I did next was stupid, but I had to try it anyway. Each post has a Delrin bushing to isolate the copper contact. These contacts are already pressed in, but I didn't solder the wires for the 2 outer posts. Delrin melts at 170 degrees Celsius, so no way it was going to survive the soldering. So what follows is me trying to save these parts. Basically what was missing to make this a true DIY project. And the problem is not even remaking the parts, it's the fact that I only have this copper left. To reface the contact surface, I took advantage of the threaded bushing and faced it on the lathe. Actually, this was only for one of the posts, only the first one is threaded. For the second, I had to make an extra threaded bushing, press it in just to reface the surface, and then change it again for a plain bushing. Meanwhile, I already had the base machine and ready for a dry build. But I also had one foot in the amp build. I wanted to have a dry build first since I wanted to deal with all the problems at this stage, not after everything is integrated into the cabinet. Testing is a big deal when you're creating something from scratch. Sometimes individual components seem fine, but problems show up when they're integrated with others. So with the switch ready, I decided to try it out and run a little integration test. I wasn't expecting anything to fail, the switch was working well and so was the PCB, but this time I decided to add an AC load to actually activate something with the switch. I had this tiny drill press at hand, so I didn't look any further. And what happened was this. I was puzzled. How is this able to pulse, with one disconnected wire? And how is it possible to have 80 volts coming out of the relay? It's off! Remember when I said I knew nothing about electronics? Really felt that here. After reading a few things, I swapped the drill press for a light bulb, and with the light bulb, it worked as expected. The 80 volts, when the relay is off, were now less than 1 volt. So what's happening? And does this represent a problem for the amp? I came across something that might be the reason, but I'm not entirely sure. The drill press has an AC to DC adapter, which might have high output impedance, and it's not syncing the ghost voltage from the PCB. The bulb, on the other hand, acts as a resistor and drops the voltage. So this might be all ghost voltage, not real voltage. And the motor? That, again, might be due to some energy stored internally in the adapter, and the fact that I'm not disconnecting both wires. But will this affect the amp? The internet says so, looks like it's a real problem. But I don't really get it, because the original switch for this type of amp also disconnects one wire only. Remember electronics first rule? Yeah, that's right, avoid at all costs. To fix this, there were these two options. Bodge it one more time with a bleeder resistor across the AC output terminals, that simulates a light bulb, or change to a double pole relay. With this relay, both AC wires get switched on and off at the same time. Going with the first option would mean my third bodge on this board. And while I'm okay doing that kind of stuff on the DC part, on the AC, I'm not so comfortable. It doesn't feel right, especially when it's a gift for somebody else. So I've chosen to make a new board, integrate the resistors on the back, change to a DPST relay, and somehow stop this flicker on the relay. That's annoying. So I turned to Erik and asked for more time. I still had the amp to finish and the entire cabinet to make. Erik's a great guy, so he said,
Absolutely not.
I was exhausted. I called for the pigeon man, but he had already flown. My muse was gone. All I could do at this point was cut down on stuff. I simplified the cabinet until it was just 6 boards. I threw the code switch in the bin, no need for the PCB anymore, but then I was breaking rule number 1, so I went back for the switch. We had a good 4-letter talk. Love, hate, fear, pain, hope, rage, loss. This project had failed after all. Grief. I miscalculated how long it would take to build the amp. Maybe my dreams were too big. I left no room for setbacks and I had too many along the way. And now there's no time to finish the amplifier for Erik. I went to bed devastated that day. But the next morning I woke up feeling different. I didn't know what it was, but there was this strange energy in me. And then, just like before, there was the flash, and everything made sense. Just tell the story, that's all I need to do. Failure doesn't really have to be failure if there's a story to tell. It's all about the journey after all. Now, there was still some time left, even with shipping, and I can be a savage sometimes, so what can you build in a day? So I made Erik a couple of base picks, one with his logo and one with mine. Overnight I also finished the switch. Makes no sense for me to keep it, so I'll send it to Erik. I wanted to make something that would last, so rust was a concern from the start. The wheels are stainless, but the posts are just mild steel, that's why I painted them. The paint is a special wrinkle paint from VHT, I've used it before on my channel and I love how it looks. So before we jump to Alex Steele's gift, let's quickly go over how the switch works. The input wire goes on the first post and is soldered to a fixed contact. Next we have these collars, 26 dimples to locate each letter. This plastic part that looks like a gear isolates the signal and indexes the letter that makes the connection. What I mean by that is that Erik can change the code. Restricted to 4 letters, of course, but it can be done. These trims will make the switch feel a lot nicer. As you know, I struggled with the design, and some dimensions weren't exactly defined before I start machining the parts. The 4mm ball and the spring go through the plastic and act as a detent, for that click we all like. Finally, we have these spring-loaded contacts that rotate with the plastic gear. When they line up with the contacts in the posts, the signal moves down the chain. Then it repeats for the next set of wheels and posts. The code should be viewed from the top, but since everything is adjustable, you can have it in any position you like. The idea was to make a black acrylic frame to cover all the other letters and leave only the ones on top visible, but clearly that didn't happen. I also tried to make it impossible to feel which letters were the correct for the code, which is why I had the contact surface machined after adding the copper contacts. Obviously this switch is just a toy, but still a challenging one to make. So yeah, this is what I came up with. I tried to keep it compact and as simple as possible, but let me know if you think there might have been better ways to do it. And by the way, I think I should maybe apologize. If you've made it this far, you basically just watched the story of the amplifier that didn't happen. At least not yet anyways. Sorry about that. I really hope this makes up for it, because now it's time to open Alex's gift. But before that, I'd just like to thank Erik and everyone that was part of this year's Toolroom Takeover. You guys rock! Oh wow! Wow, it's beautiful. I kinda knew what it was. Customs, you ruined this for us. But I had no idea what it looked like. It's beautiful. I love the steel logo. Thank you so much, Alec. Now the question is, does it fit? So Alec made me a gear knob for my Mini. Unfortunately, this car has been sitting still for the past 5 years. The word on the street is that I even started a YouTube channel just to avoid finishing the car. Can you believe it? The audacity. Tsk. Anyway, I can't show the knob in this Mini right now because it doesn't have the engine. It's rebuilt, just not in the car. So what I can do, just this once, is showing the knob in my other Mini. By the way, did you notice knobs with a K? Just like Erik? Are you connecting the dots? Well, it does the job. I was trying to figure out how Alec made this. And obviously this was forged. But the question is how? Alec's been playing a lot lately with 3D prints and some PLA patterns. And then this was laser engraved. And I thought this was brass. But I just talked with Alec and this isn't brass. This is 24 karat gold. So I'll leave you with that piece of information and a thought. Next video, making a vault with a 4-letter code. Until then, click here to watch Alec making these or here to watch Erik opening 10% of an amplifier. See ya!
Yeah, we're happy.